controls B. So A has control of the handlebars on the bicycle. It's controlling the bicycle, right? So A is controlling B. So that's one way to remember it. So if you see this symbol, what it means is that B is a subset of A. A is the bigger set. B is the smaller one. Now you could have two sets like this that just they're the same set, right? A and B. So all members of a B are in A, and in fact all members of A are in B. So that's why you have this equality. So that would be, let's say B is strictly smaller than A, but if you have this bar underneath, that allows for the possibility that A and B are in fact the same set, right? So a subset can be the set itself, right? So B could be A. That's a possibility. Now, if it's not, if you want here's where this concept comes in. A proper subset. A proper subset means this without the equals, right? So that means that B then is strictly smaller, has less elements in it than A. So if you don't have this equal line here, if it's just B, oops. So that means that B is a proper subset of A. Okay. Right. So if you're told two sets are the same, what does same mean? What does that mean in the context of set theory? Well, it just means they have the same elements, right? So set A and set B, if they're the same, their elements are the same. So fairly simple definition. Okay, now Venn diagrams already started to use a bit. They're very, very useful. So to specify or represent a set using a Venn, V-E-N-N, some mathematician, actually I should find out a bit. I need to Google him or Wikipedia him. Who was Venn? That's something I've known about for decades but never really bothered to find out. Okay, so maybe you could Wikipedia V-E-N-N or Google V-E-N-N, find out who and where he worked. Okay, so a Venn diagram is you just draw like an oval that represents the set. So let's say set A, and then dots inside the circle, and they represent the elements or the members of the set. So you could say this is element A, and that's element B and C and so on. Okay. Now, using Venn diagrams, we can introduce some concepts called intersection and union of two sets. So, do that now after clearing a bit of space. So the intersection of two sets. So here's one set. We'll call that set A, and this is set B. By definition, the intersection of these two sets, using two Venn diagrams, two ovals, it's those points here. Those members. Okay? So in other words, let's call the sets. Let's call this set here C. This is set A and set B. So set C is the set of elements that belong to both A and B. Right? They intersect. So C is the set of elements, let's say X, such that X belongs to A and X also belongs to B. Right? So we're specifying the set using a description in this case. Okay? So now there's a shorthand way of writing this. We just do it this way. C is just A and then a sort of, let's see that. Okay, so it sort of looks like a semicircle, so sort of like this. That's the intersection sign. Okay? So so the intersection of two sets is the set of elements that line both sets. Yeah? So these points here, where the two sets overlap, so to speak. So intersection, overlapping, sort of the same. So the intersection is the set of those elements that belong to both A and B. Okay. Now the union. I'll draw the union. This is the union. I'll try a new pen. I think this one's drying out a bit. Now, the definition of this is, let's call it D, and it's written, instead of a semicircle this way, it's written that way. So it's written like this. Okay, and its definition, it's the set of elements X, where X belongs to A or X belongs to B. So in other words, it's the set of points in A and B, in either of them. Right? So the or here is critical. Okay, so that's the union. So if you have two sets A and B, usually the intersection will be much smaller than the union. So the union of two sets will be bigger than usually set A or set B, and the intersection of A and B will be usually smaller than A or smaller than B. Okay, it's just common sense. You can just see it from the Venn diagrams. Okay? Now, what happens if two sets have no elements in common? For example, here's a set, but just set of the two numbers 1 and 2, and here's another set, 3 and 4. So the union of these two would be 1, 2, 3, 4. Okay? But what about the intersection? So if I intersect these two sets, what happens? Well, there's nothing in common, right? There's no element that's in both sets. So I get, well, I get like an empty set. Okay? There's just nothing in it. Now, the empty set has its own symbol, and it's this one. So it looks sort of like a 0. It's a 0 with a stroke in it. So the empty set, like just left wiggly bracket, right wiggly bracket with nothing between them, is usually just written like this. Okay? So if you see that, you just think the empty set. And an empty set is a set with nothing in it, no members. Now, if the intersection of two sets is the empty set, what do you know about A and B? Well, they have no members in common, right? And if that happens, if two sets have no common members, those two sets